Welcome to a video going over your soil lab summative. This is going to be an out-of-class summative with some work time on Friday and Tuesday. It will be due at the end of the day on Tuesday, and really you're still being graded on your ability to write and talk about a claim that's logical, focused, and supported with relevant evidence, but I'm also going to be looking at you being able to make connections between types of data, specifically data that we collected and data from other sources. When you are proficient, or if you are proficient with this assignment, you will be able to have claim-based arguments that argue an answer that's specific to either a hypothesis or question. 2, you're going to be able to either construct or utilize data tables or graphs that are useful for helping support and construct your claims. And finally, classroom vocabulary and concepts are both utilized and contextualized and expanded upon in your work. So you're not just saying fundamental niche, but you're using it in a way that helps me understand that you know what this means and it furthers your overall argument. What I might do tonight after you watch this video is start copying and pasting data tables and figures and graphs that might be useful for you to help answer the 3 questions that I'm about to go over. Now, before I go over those questions, I just want to talk about your data sheet and the PowerPoints that you have for use. First being the data sheet. Now, in this data sheet, you have teams, you have tree species, and then you have over here things like the percent moisture in the soil, the percent sand, silt, clay, and also soil type. My thought is that every time you want to make a certain set of data, you just duplicate it. And that allows you to always keep this tree data as a backup in case you make some oopsies. So I'm just going to call this sort by tree. So what I'm going to do right now is show you how to sort data. Sort range. I need to highlight all of it. Sort range, advanced range sorting options, data has header row, tree species, A to Z, and now I have all my data sorted by different trees. This might be really useful if you're answering one of the questions. We also have information in terms of a specific group, how many trees they sampled, and within that sample, how many of them were different types of tree species. Generally, if you see bigger DBHs for the data, it will probably mean that that tree was bigger and healthier. And that is another thing to possibly consider, but it's not that important. So let's go over the PowerPoints. You'll have a whole laundry list of these available starting tonight, where you'll be able to look at the figures, the factors that are important for Vermont, where we find it in the United States and how common it is in throughout that, how it responds to precipitation and temperature, how it responds to elevation and latitude, and then soil permeability and pH. A good note is that as you increase permeability, you're tending to decrease clay and increase sand. Sand is very permeable and clay is not. You also have scatter plots that you can use, and also computations that have the averages and the ranges and the standard deviations for clay, sand, silt, and sometimes moisture. Standard deviation just means how error prone your data is. A smaller value in proportion to the average, the better. So actually, when I look at the standard deviation, sand and silt are pretty good. Clay is a little error prone. 6.82 compared to 10, that's not the best set of data. And you also have people's initial arguments for what they think a tree is in terms of being a specialist or a generalist. So let's take a look at the 3 questions that you have. You should first get data, so tables, figures, graphs, and I've shown you each of what that will look like. I'll put a graph here later. So here's the first question. With supporting evidence from niche maps, ranges, and the Vermont table factor table, the factor table being this guy right here, can you argue if we collected evidence being our data sheet, that shows, based on soil preferences and locations, a species as being a specialist. So that means in this argument, you're going to be identifying one tree species that you would consider being a specialist. And it's going to be a specialist based on soil preferences, which would be column AB, sand, silt, and clay, but also how often we found it and in which sites. Within this argument, I think you should do the following things here. Establish what species you're arguing as a specialist and the background info that supports this. 2, locate and cite data from either specific sites or locations that show how this species is a specialist. And C, compare and contrast the background information with the collected data. So this is where you would talk about background information that either supports or maybe contradicts the data that we collected. And you can think about that in terms of accuracy, precision, similarities, and differences. The second question I want you to do is to compare and contrast two different sites and argue why one might be dominated by one species and another is more diverse in its species diversity. With this, I'm really thinking about a team that shows a lot of different species versus a team that shows one or two species. And I'm trying to think about what is it about these factors that I collected here that might demonstrate why one species is very dominant while another site has a wide variety. Within this argument, you would want to establish which site is considered more or less biodiverse. You might want to talk about concepts of niche size, fundamental and realized niche, and abiotic factors that might influence this. You're probably going to want to reference and discuss the tree species in either both or either sites and argue why they might be a specialist or a generalist, and then cite abiotic data from your sites that demonstrates why that site would be really important for creating a biodiverse or not biodiverse site. I will say that the moon, cloud, lightning bolt question on your quiz might be a good benchmark for thinking about this aspect. The last question is really open-ended, and honestly, there's probably more than one right answer for this. I know there is. I have given you a location on Mount Mansfield that just experienced a landslide, which means it's a clear, open plain. You want to use these factors, soil pH, soil permeability, clay, elevation, rainfall, and soil moisture, to think about what type of trees might grow here. Now, I've also given you the range. The range might be important to think about how restrictive or how broad each of these factors might be. For example, I might argue that clay is way more of a broad variable than elevation based on these two averages and ranges. You also have in your slides 5, 6, and 7 really specific or broad requirements for each tree species. I think that there is an easy way for you to argue either being a specialist or a generalist forest, but I really want to see your thought process in action. So, those are the 3 questions. Again, for proficient, you're going to be making connections between data, and scientific concepts, and vocabulary, and you're going to be using that vocabulary and concepts to make a claim that is explaining the significance of your evidence. To get a 4, this would be where you really wow me with that last question about Mount Mansfield, applying connections to a new or more complex solution, and you're also comparing and contrasting evidence that makes sense with evidence that doesn't make sense based on what we collected and what maybe the Forest Service found. I think that you are all very capable of doing super well in the summative. You have tomorrow and Tuesday to ask me questions, ask for support, and also to work on it over the weekend. I think that 1 paragraph per answer is enough for you to demonstrate a 3 or a 4 on this assignment. Please reach out with questions. I'm here to help all of you, and take care.